Hello everyone, let's learn about molecular orbital theory. Okay, according to molecular orbital theory, atomic orbitals, okay, this is your atomic orbitals, combines to form, they will combine to form new orbital. So new orbital, these two will combine to form new orbital, and this orbital will be known as molecular orbital. Okay, so atomic orbital combines to form new orbital. Okay, once the molecular orbital form, their identity will be lost. Okay, once molecular orbital form, then their original identity will be lost. Their original atomic orbital character will be lost. Okay, next, second point, the number of molecular orbital formed. Okay, the number of molecular orbital formed are equal to the number of atomic orbital overlap. So how many, here see how many atomic orbital has formed? 2. Okay, the number of molecular orbital formed, how many is formed? Here it is 2. So are equal to the number of atomic orbital overlap. Here we have taken how many atomic orbital? 2. As we have taken 2 here, we are going to form here 2 molecular orbital. That means how much number of atomic orbital we take here, that much amount we are going to form the molecular orbital. Okay. Third, only those atomic orbitals form molecular orbital which have comparable energy. So we are taking atomic orbital here, another atomic orbital here, and if we observe it here, this is 1s, this is also 1s. That means they have same energy. So or in some other cases similar energy, a small amount of energy gap, then they will be able to combine, overlap to form molecular orbital. For example, here see, if I have taken 1s and 2s, and they have energy difference between them, and they cannot form molecular orbital. So in order to form molecular orbital, the combining atomic orbital should have same energy, or the difference of energy should be very small. Okay. Fourth, when atomic orbital combine or overlap, they form 2 types of molecular orbital. Okay, 2 atomic orbital we have combined, we are going to form how many molecular orbital? 2. Okay, so 2 are formed, and these 2 are different, are of different types. The lower part will be formed in this way. The lower part is called the bonding molecular orbital, and the other part, the higher, which remain in the upper part, it is called anti-bonding molecular orbital. So the lower part has lower energy, and the higher one, the above part, has higher energy. Okay. Then molecular orbitals are represented by sigma pi. Okay, we will represent it by sigma pi. So whenever we represent for bonding, there will be only sigma pi, but when we represent for the anti-bonding, then we will put star, sigma star, pi star. Okay, so these are the theories or postulates of the molecular orbital theory. So by following this theory, we are going to write the molecular electronic configuration. Okay. Now here I have written what? The electronic configuration of a molecule up to electrons, and the electrons should be less for this, the electron should be less than 14 or equal to 14. And here we are going to talk about those molecules having total electrons 14 or less than 14. In that case, the electronic configuration of that molecule will be written as, okay, just very simple, sigma 1s. Then once again repeat sigma 1s, but put star. Okay, sigma 1s, sigma star 1s. Sigma 2s, again, once again you write sigma star 2s. Okay, star will be there. One is non-star, one is star. Then pi to px, pi to py, sigma to pz. Then again these two have similar energy. Okay, so then goes on pi star to pz x equal to pi star to py, then lastly sigma star to pz. Okay, how it has come, let us see it. Okay, for normal electronic configuration, as we write for the atom, that is what we write as 1s, then 2s, then 2p. In p there is how much? Px, py, pz. So we go on writing in this way. But in the molecular orbital theory, the electronic configuration is represented by sigma 1s. How it has came, we will follow the rules. Okay, we will follow the rules. So what is the first rule? We have studied atomic orbitals. Okay, atomic orbitals combine to form new orbital known as molecular orbital. Okay, in this way we are going to combine, see, we are going to combine 1s atomic orbital, this is your atomic orbital, 1s atomic orbital, okay, and another atomic orbital 1s. We are going to combine 1s and 1s. So 1s combined will give 2 molecular orbitals. So this will be your molecular orbital. So 2 atomic orbital combine to form 2 molecular orbital, and there are 2 types. This will be the lower energy level, one will be in the upper energy level, and these 2 will combine and form 2 molecular orbital, which is represented by sigma 1s, and the higher one will be always sigma star 1s. Okay, so 1s and another 1s will combine to form 2 molecular orbital, that means sigma 1s and sigma star 1s. In this way 2s atomic orbital and another 2s of the atomic orbital will combine. Since these 2 combined will form 2 molecular orbital, one will be the upper and one will be in the lower. So and they give a new molecular orbital called sigma 2s, then the higher one will be sigma star 2s. Okay, next, what is that? P molecular orbital in the normal atomic configuration is P, 2p. So 2px, 2py, 2pz. So in this way another atomic orbital has 2px, 2py, 2pz. So they will combine to form molecular orbital, okay, which we call it as pi 2px, pi 2py. Okay, so pi 2px, pi 2py. So this of lower, and another will form in the higher case, that is what, in the higher also. Then in the higher case we just put as pi star 2px, pi star 2p, pi star 2py. Okay, now this px and py has already completed. Px and py has already completed. They combine together to form 2 atomic orbital. So okay, these 2 combine, these 2 combine. How many orbitals? See, 1 2 3 4. So how many has formed molecular orbital? 1 2 3 4. Now what is left? Pz is left, pz is left. Okay, so these 2 will combine to form another molecular orbital. So we will have sigma 2pz. Okay, this is the lower one. These 2 will combine and form 2 molecular orbital, one lower, one upper. So this one will be the upper part. Okay, so this sigma star 2pz. Okay, so in this way we are going to draw the molecular orbital theory. Okay, so just check it. So this is only for the molecules having total electrons up to 14 and less than 14. Okay, in the next video I'm going to talk about electronic configuration of a molecule having greater than 14. Okay.